Finish up with a talk about deployment, which means putting a model into production. So this chart, by the way, comes from a website, and I will give you the reference for the website. It's an organization called CRISP-DM at www.crisp-dm.org. And that stands for the Cross Industry Standard Process Model for Data Mining. So it's a modeling methodology, and the way we walk you through it is as follows. We assume that you're an analyst working in an organization and you have a good business understanding of your data. And once you have a good business understanding, this gives way to a data understanding, meaning you know the rows and columns, you know what you can extract from your information and what you can't extract. We also assume you're pretty familiar with the data preparation techniques at some level. We call this ETL, meaning the ability to extract, transform, and load your data in certain ways. And then finally, as you've seen from the previous example, a lot of what we are doing involves different modeling techniques, which means you're building a predictive model to figure out an outcome. You're going to score that outcome. And once it's scored, you're going to evaluate the effectiveness of that model, which we've not really yet done. The effectiveness of a model is gauged using what's called an ROI evaluation chart. That's another key word I want you to write down. Another name for this is what we call a gains chart. And the whole idea of the ROI evaluation chart is to tell your management the economic benefit of using the model. Because if there's no economic benefit, there's no model that you can put into production, there's no reduction in costs, and there's no gain in the amount of revenue that the model will produce. Once you're in evaluation mode, then you're going to deploy the model, you're going to put it into production. I want you to write down these keywords. It's called champion challenger. Champion challenger means you're going to have one champion model and multiple challenger models. I like to build 5 challenger models and have one champion. And then you're going to track those models to see if the accuracy rate is trending up or trending down. Accuracy rates flip-flop over time. Sometimes a model that works well in the month of May will suddenly degrade and become useless by the month of June. That's why you need multiple models. When you're monitoring these models in deployment mode, you're going to learn from what these models provide. This whole exercise, by the way, has a buzzword called test and learn. From the credit card industry, I want you to Google test and learn in credit card industry to understand how the credit card industry implements production models. Because when a model is put into production, it kind of looks like this. You have a control chart, you have basically the accuracy rate, let's say it's at 90%. Over time, the model degrades and becomes less accurate, and you swap in a new model as the old model degrades. That's a true deployment exercise. Once you've gotten through the deployment mode, you now have additional understanding about your business, which means you have a closed loop. You're getting smarter and smarter about your business every 30 days, 60 days, or 90 days, however long it takes you to do the full model development life cycle. Yes.
So when you swap in the new model, does the new model use the same test data, or you can incorporate the new data that you acquire?
You may need to incorporate the new data, especially if you have a shift in your population. This happens with very unstable industries. For example, in the credit card industry, if you lower the interest rate on your loan, you're going to get new customers you never dreamed of before. Mostly in marketing situations, or if you're in the manufacturing industry and you take on a new supplier, that supplier might have a very different quality level to their material. You might see the model changing for figuring out failure rates. Let's say you're a circuit board company, you bring in a new supplier of copper-clad alloy, and the circuit hits and dents go up. That's because you brought in a new supplier, you have to build a new model. You've changed something at a very important level in the process. Any questions about any of these terms? By the way, I like that CRISP-DM website. It's got a lot of good information in terms of introducing your management to the concept of data mining. Okay. So the data mining techniques that we will go through, kind of like in rapid fire mode now, we're going to do 3. The first one is classification. We already did one classification example, but this involves predicting group membership. Will an employee leave, or will somebody attrite or be retained as a customer?